In this video, we're going to prove this really nice fact. There are no arithmetic progressions which are in this form that contains solely primes. Okay, you can't come up with A and B where A plus any multiple of B is always prime. Is prime for all multiples of B. B positive. M is Z positive. You can't do that. And if you like to see why this can be, you should watch to the end of this video. In fact, if you like to see mathematical proofs, you should definitely subscribe to this channel. So now, there are going to be two cases. Suppose A plus 1B, A plus 2B, etc. consist entirely of composite numbers. Now, I'm not even saying that that can be true. Well, that implies that A plus 1B, A plus 2B, etc. certainly doesn't contain solely primes. It contains no primes. Okay, so suppose, on the other hand, suppose A plus 1B, A plus 2B, etc. contains a prime P. Then, for some n, P is equal to A plus NB. Okay, because to be on the list, I'm claiming that this number P is on this list. Well, to be on the list, you have to be a number plus a multiple of B, an integer multiple of B. So, for some n and z, P is A plus NB. In fact, n is positive. Well, the first one is 0B. So, why don't we formally say that? For some n greater than or equal to 0 in the integers, we have that P is A plus NB. Now, I just need to show that there is at least one other number of this type. I need to show that there's one number. I need to find a number of that type that is composite. Well, we know that it has to be in the form of A plus a number times B. And this number needs to change. It needs to increase. Well, I know that if I put an n here, so far I have A plus NB. Ooh, that's good. That's P. I want to be able to factor this. If I can factor this, then it's not prime. So you know what? I'll add PB. In fact, I'll add PK in there, where K are positive integers. Okay, so what this tells me is that this here is equal to A, that A, plus NB, plus PKB. Now I'm going to put brackets around there because that's a special value. That's P. This is P plus PKB, which is P times 1 plus KB. And at worst, so now this product is not prime if this number is 1. Well, it's a linear equation in K. The most you're going to get is one integer value for K. In fact, I made a mistake. We want to know when this is 1, because we really can't allow it to be 1. Well, 1 plus 0 is 1. So we don't want KB to be 0. Oh, just don't let K equal 0. Okay, for almost all values of K, this, or for infinitely many values of K, this is not 1 and this is P. So this, whether this is prime or not, it's more than 1 and this is not 1. That's composite. That's composite. So I found an infinite number of numbers in the form A plus NB that are composite. This is composite. That is, it can't contain solely primes. In fact, it must contain an infinite number of composites. Either all of them are composite, or all of these infinite number are composite, and maybe some are prime. Well, at least one is prime. At least one is prime. That completes this video. If you like mathematics like that, where we think, which is quite important in mathematics, then you should definitely subscribe to my channel, as that's all we do, is we do mathematical proofs and we argue why the proofs are valid. Subscribe to my channel, like this video. See you guys in the next video. Watch and learn.